This question comes from Max, who asks, what if we moved Earth to another solar system?
At first glance, it sounds like science fiction on steroids, a planet-sized spaceship. But let's explore what would really happen.
First, we have to think about how we would move the Earth. The planet weighs about 6 times 10 to the 24th kilograms.
To give it even a tiny push into interstellar space would require more energy than humanity has ever produced. We're talking about harnessing the energy of an entire sun for centuries, or maybe millennia.
Assuming somehow we manage it, let's look at the journey. Earth is traveling at roughly 30 kilometers per second around the sun. To leave the solar system entirely, we'd need to overcome the sun's gravitational pull, an extra 12 kilometers per second at minimum. Once in interstellar space, Earth would drift through near-perfect vacuum with no more sunlight. Without sunlight, photosynthesis would stop immediately. Plants would die within days, and the food chain would collapse.
Temperatures would plummet. The average surface temperature would drop to about minus 270 degrees Celsius, just a few degrees above absolute zero. Our atmosphere might eventually freeze, with nitrogen and oxygen turning into liquids and solids.
But let's imagine we somehow protected life with enormous energy shields or artificial light sources. We'd need continuous power to replace the sun's energy.
Even covering the entire planet with artificial light would require trillions of times more energy than humanity currently produces. The surface would feel like an artificial greenhouse on a cosmic scale.
Gravity on Earth would remain the same, so structurally we'd be okay. Oceans wouldn't fly off, but without sunlight, water would eventually freeze solid.
And the sky? It would be permanently black except for distant stars. No more day or night cycles based on the sun, just an eternal night punctuated by artificial illumination.
The planet's orbit around another star introduces new challenges. Most stars aren't identical to the sun. If the new star were brighter, Earth could overheat.
If it were dimmer, even more artificial heating would be needed. And if the orbit were elliptical, seasons could become extreme, one side of the planet baking, the other freezing.
Even cosmic radiation would be a bigger threat. Our solar system's magnetic field shields us from a lot of high-energy particles.
In another star system, or in interstellar space, Earth would be exposed to cosmic rays. Without additional shielding, life on the surface would face deadly radiation doses. Let's not forget the Moon. If Earth's trajectory changes, the Moon could escape orbit or collide with us.
The tides, which regulate oceans and some ecosystems, would be disrupted or disappear entirely. Artificial stabilization might be needed just to keep the Moon tethered.
Collisions with asteroids or rogue planets could become more likely too. Our solar system is relatively well mapped, but in another star system, unknown objects could strike Earth. Even a small asteroid impact without the sun's thermal forces could have catastrophic consequences.
So, could humans survive? Technologically, survival would require a combination of massive energy generation, advanced shielding, and strict ecological control.
Cities might need to be entirely self-contained biospheres. Agriculture, weather, and even air composition would have to be artificially maintained. On the upside, Earth's gravity, oceans, and atmosphere would give life a better chance than colonizing another planet from scratch. We'd retain familiar landscapes, ecosystems, and environments, provided we can sustain energy and light. But it's an engineering and energy challenge on a scale almost impossible to imagine. In the end, moving Earth to another solar system is theoretically possible, but practically, it would be a cosmic-level miracle. Life as we know it would survive only with constant, intensive artificial support. And while it sounds like science fiction, thinking about it helps us appreciate the delicate balance of our planet and the sun that makes it all possible.